In this video, we're going to look at the specific stoichiometric calculations that we will be doing in this chapter. So again, there's going to be 4 types of calculations that we'll be responsible for. And again, here's the basic setup. They're going to give you the amount of some chemical in a chemical reaction, and they're going to want you to solve for some other chemical within the chemical reaction. And the information that you're going to be given, you're either going to be given the moles of a chemical in these first 2 situations, or you're going to be given the mass quantity of the first chemical. Then they're going to ask you to solve for either the mass or the moles of some other chemical. And these are the number of calculations or steps that we'll have to do. And I said this back in the section 1 video. A and B have nothing to do with reactants or products or left side of the reaction or right side of the reaction. A is simply the chemical they tell you, whatever it is. And B is the chemical they want you to find, whatever it is. Does not matter where it's written. Now, think, okay, we're learning some new type of math. No, we're not. Here's anything else that we would have learned before. If you're given a quantity of anything, you're going to multiply by conversion factors, one or several, so that you can solve for some unknown quantity. For example, you're given a certain number of quarters. Did this early on in chapter 3. If you're given a certain number of quarters, 44, you're going to multiply by a conversion factor, $1 4 quarters, and that's going to give you the answer $4. There could be a time thing where you have 4,932 seconds. Multiply by whatever conversion factors we would need so that you can find the number of hours that are in a day or in that time frame. So obviously we'd have 2 conversion factors here. 60 seconds in a minute, 60 minutes in an hour. We'd have to use both of those. That's all we're doing here in chemistry. Same thing. So we're not learning any new calculations. The first one that we're going to look at is the simplest one, but it's probably the most important. Moles to moles. So you're going to hear me say that phrase. Hey, this is a mole to mole problem. So if we look here, this is the sample problem they have in section 1. And the very first sample problem on page 305. You read the question, and here's basically the reaction. They tell you there are 20 moles of carbon dioxide in the reaction. How many moles of lithium hydroxide will be needed to produce the lithium carbonate and the water? Okay? So chemical A is what we're given. Chemical B is what we're trying to solve for. So we start out with the chemical that we're given. And again, don't just write the numbers. You got to write out the formulas and all that stuff. Otherwise, you guys are going to have a tough time. We're given 20 moles of carbon dioxide. And we want to multiply by a conversion factor so that we can solve for moles of lithium hydroxide. So what is this conversion factor? Is a conversion factor that relates moles to moles. Well, this is a mole ratio conversion factor. Where do we get it? It's the coefficients from the reaction. So you can look there on page 305. And again, this is how they set up a lot of those problems. They're first going to sort of show you what to do, and then they're actually going to show you the steps. And what we're trying to look at here is, all right, what's the ratio of carbon dioxide to carbon monoxide? Like any other conversion factor, we put on top what we're trying to go to, we put on the bottom what we're trying to get rid of. Well, the coefficients are 1 to 2 or 2 to 1. So for every 2 moles of LiOH, we have 1 mole of CO2. Moles of CO2 cancel out, just like we've done conversion factors before, and it's 20 times 2. So if we want 20 moles of carbon dioxide to react, we're going to need to supply 40 moles of LiOH. And again, that makes sense here. The reaction says if this is going to work, they've got to be in a 1 to 2 ratio. Okay? So that's what we're trying to do there. All right. Very next thing, they have a practice problem there on top of 306. It says ammonia is a widely used fertilizer. How many moles of ammonia are produced when 6 moles of hydrogen gas react with excess nitrogen? So the first thing you're going to have to do is figure out the balanced chemical equation. they tell us there how many moles of ammonia are produced when hydrogen gas reacts with excess nitrogen. Don't worry about the 6. That's the amount. You first have to know what's the reaction. Well, there's the balanced chemical equation. So this is kind of like chapter 8. Now, what do they tell you about the amounts? You are given 6 moles of hydrogen gas. So if we have 6 moles of hydrogen gas, how much NH3 will be produced? Well, in a simple aspect, you can look here. What's the ratio of the two chemicals? What's their proportion? They're in a 3 to 2 or 2 to 3 ratio. So what are we going to do? We're going to do an A to B problem. We're going to go from the moles of chemical A, which is hydrogen, to the moles of chemical B, which is ammonia. So we write out what we're given. We're given 6 moles of hydrogen multiplied by a conversion factor to get 2 moles of ammonia. The conversion factor is the coefficients, 3 and 2. How do we get 2 moles of ammonia? Well, moles of ammonia goes on top. Moles of hydrogen goes on the bottom. 6 times 2 divided by 3, 4 moles of ammonia. So if we introduce 6 moles of hydrogen gas in this reaction with an excess amount of nitrogen, unlimited amount, we're going to make 4 moles of ammonia. So that's what we're looking to do. All right, so here's what I want you to do. On the second practice problem, on page 306, you need to show me your answer, or show me your work. The answer you can check in the book. And so that I know that you were able to do that one and that kind of made sense. All right. Okay, so let's look at the next type. Next type is a mole to mass problem. So again, they're still introducing you with an amount of moles, but now they're wanting you to find the mass of a second chemical. Not the moles of the second chemical, but the mass. So we really now have a 2-step calculation. The first step is we need to go from the moles of some chemical to the moles of another chemical. Well, that's simple. We're going to use the mole ratio. And you're going to hear me say the phrase over and over again, it's B over A. B's coefficient over A's coefficient. That's what it'll always be. B over A, B over A. So you'll hear me 1,000 times in the video, and you'll hear me say it all the time in class. Good. That's the first part. Well, now the second part is, I've got the moles of a next chemical, but now I need to go to its mass. Well, that's a calculation we've been doing since chapter 3, and chapter 7. How do I go from the moles of a chemical to its mass? I need to use its chemical's molar mass. So there's where it's a 2-step calculation. I'm using 2 conversion factors. I'm using the coefficients from the reaction, and I'm also using one of the chemicals' molar mass. Add up its formula. So we look at the sample problem on page 306. Okay? It's a simple photosynthesis. Read the question, and it says that if we have 3 moles of water, how many grams of glucose would be produced? Okay. We're not saying how many moles, we're saying how many grams. So what we're going to do is we're going to go from moles of water to mass of glucose. Problem is it's not a one-step calculation. We're first going to go to moles of water, then to moles of glucose, and then finally to mass of glucose. Okay. So if you look on the sample problem there on 306, they go through that calculation, the steps. The 2 conversion factors are going to be first moles of water to moles of glucose. Using mole ratio, not molar mass there. Good, using mole ratio. Then moles of glucose to mass of glucose, we're now going to use its molar mass, C6H12O6. So you can see in that sample problem how they're setting that up, and they're actually solving for the answer. So 3 moles of water will produce 90 grams of glucose. Okay. So we're taking the first part of this calculation is what we just learned. The second part of the calculation we already know how to do. Okay. Now what I want to do next is if you turn to page 308, here's the first practice problem. So we read that, the first practice problem, they actually give us the reaction, and they're asking what mass in grams of magnesium oxide is produced from 2 moles of magnesium. So you want to know what's the mass of MgO if we're given 2 moles of magnesium. Again, we recognize this is a moles to mass problem. Okay? We're going to go from moles of magnesium to mass of MgO. Moles of magnesium, we first have to go to moles of MgO, then moles of MgO to mass of MgO. How do we go from moles of one thing to moles of the other? Coefficients. B over A, mole ratio, proportion. How do we go from moles of magnesium oxide to mass of magnesium oxide? The molar mass of it. So our calculation is simply 2.00 moles of magnesium multiplied by the mole ratio. Now here's what's kind of interesting is they both have the same mole ratio, so it's 2 to 2. So for every 2 moles of magnesium oxide that are made, 2 moles of magnesium are consumed. Moles of magnesium cancel out. Now we need to go to mass of magnesium. So in 1 mole of MgO, we have the molar mass of magnesium oxide. So we're going to add the molar mass of magnesium, which is 24.305, and we're going to add it to oxygen, 15.999. So call it 16, 34, 40, 40.304. So now we have the molar mass of magnesium oxide, and all we're going to do is add this calculation, multiply everything out in this calculation. And we do this 2 times 2 over 2, that all cancels out. So basically it's 2 times 40.305. Actually, I think I said 40.304. Again, depending on which periodic table you have. So when we multiply this out, we're going to get 80. Now we got to watch significant figures here. We got 3. 80.6 grams of magnesium oxide will be produced from that original 2 moles of magnesium. All right, part number 2. I want you to do practice problem number 2 and be able to show me the work in class. So what we've done here is we've done 2 examples. We're halfway there, and what we're going to do is in the next video I will show you the last 2 examples of the calculations we're going to do in these stoichiometry situations.